Hello there, I hope you're all doing well. So we'll begin our lesson today. We'll be looking at fossils. So first of all, let's go through our glossary of keywords. Petrify. So petrify is to change into a stony substance. So for example, if you have a petrified wood, it means that wood that has been changed into a stony form. And the other keyword is paleontologist, a scientist who studies the history of life on Earth by using fossils. A scientist who would study how or the existence of life previously using fossils. So by the end of the lesson, we should be able to tell what a fossil is, and also describe how fossils are formed, and also to know the importance of fossils. So looking at the picture on the slide, what comes to mind? Some of you might have seen this somewhere before, others too, I'm sure this is your first time of seeing these things. So these are, we call them remains of organisms that used to live. You would realize that the one on the right, it is not the organism itself, it's just a trace of the organism. So this is not the organism. So that's what fossils are all about. If you look at the one on the left, the picture on the left, it is not really the structure of that organism. There are other rocks that has also been incorporated into the body and then has given you that structure over there. That's from the previous slide. If they are not quickly buried by the soil, they are going to be decomposed by microorganisms such as bacteria and fungi, or they could be eaten by other organisms. For example, scavengers like vultures that eat dead animals. So when they are quickly buried by the soil, they are not exposed to these things. So after they've been buried, you have the soft part decaying, then it leaves the skeleton part. Now the soil which surrounds it over a very long time now becomes rock. It forms a rock around it. Then, if I'm sure you know that there is water beneath the soil, call it underground water, and this underground water normally contains what you call minerals such as calcium, magnesium, phosphates, and then the rest. So normally some of these bottled water that we drink, like Belacqua and Voltic, some of them are actually sourced from underground water. So you hear them make claims that they contain minerals, and it is true because underground water contains what? Minerals. Now, so these minerals will then enter into the organism inside the rock. So take note, the minerals from the water will penetrate the rock. So you would guess that this rock is going to be a type of rock that would allow water to enter into it. And we've done types of rocks. You know the type of rock which allows water to penetrate it, and you know that is what? Sedimentary rock. So it gives you the idea that fossils are more likely to be formed with sedimentary rocks than igneous or the other types of rocks. So take note of that. Now, when the minerals from the underground water gets into the fossil as it's forming inside the rock, what happens is that these minerals are like metals, as it were. They then enter into their skeleton. They make their skeleton harder than before. Now when this happens, you say the fossil has been formed. Now when they become very harder, it means that they wouldn't get spoiled in no time, or in other words, it's going to last for years. It's going to last for years. So that's how come some of these fossils, like the dinosaurs, although after so many years, some of them, according to the scientists, are about millions of years old. So it takes a very long time for these things to be formed. So the fossil is formed, and then after so many years, through some activity, digging up or something, then the scientists go to discover some of these fossils, just like what they did with the dinosaurs, and then they got to know that dinosaurs used to live on Earth when they dug up their fossils and then identified them. And so this is just a flow chart diagram of how fossils are formed, taking a fish as an example. So first of all, the fish will start out living its normal life, then it dies, goes to the ocean floor, then it is buried. It's buried by the rocks and then the sand and all that. Then inside the rock, then it begins to harden, just like what you said, inside the rock. So the minerals from the underground water will harden it. Then over a very long period of time, it will get exposed, and then you see the scientist over there with his hammer trying to dig it up, and then he gets this fossil of the fish. Alright, so over here we would watch this video. This is a video of how to make your own fossil using plaster of Paris. So you could watch that. So this is how the fossil looks like. So that's a fossil of a dinosaur, as it were. So you need a plasticine, or what we call Play-Doh or Play-Doh. So you have a toy of a dinosaur. You just mold it around the dinosaur. So you see, when you do this, it's going to create a trace. You see, it's going to create a trace. That's why we are saying that fossils are not always the organism itself, the remains of the organism. It could be a trace. So you pour, this is the plaster of Paris. It's normally used to design ceilings. So it becomes hard after some time. Normally, you see, when you go to certain buildings or certain rooms, you have their ceilings designed with some pattern, some design. They use the plaster of Paris to do that. It's just like what he's doing. They also mold it in a design from whatever design that you want, and then it registers well, just like this one. So you dry it for some time, and this is your fossil. You have your fossil. So got it. So why are fossils important, or fossil records? Fossil records are basically fossils that are being used as evidence for certain purposes. So why are they important? Why are we even studying it? Why is it so important, fossils? Now, number one reason why it is important is that it has been used to determine some of the oldest plants. One scientist by the name Claudia Rubinstein and then her team found an ancient form of the plant liverwort. Liverwort is a plant. So this is a modern day liverwort. This is not the ancient one that they preserve. No, this is just a modern day liverwort. So it's very small. It doesn't have too many branches, just very small, like a herb. Now, so when they found this fossil, they realized that it had lived more than 470 million years ago. So this is what I was saying. Fossils don't form within a day. Fossils don't form within a month. It takes a very long time to form fossils. It takes a very long time. It can span over your lifetime to other generations before fossils are formed. So when they were able to discover this year, that it had lived for this number of years, they could make certain deductions, saying that perhaps since this plant, this liverwort plant, from its fossil records is that old, perhaps all other plants that we are seeing now may have evolved from that plant. So fossils are so important. It helps scientists a lot to determine evolution and all other things. For example, I'm sure you've heard of the evolution, or the idea that human beings came from apes and monkeys and all those things. They use fossils, also fossil records, to also be able to arrive at that decision. Okay, so now let's move on to another reason why fossils are important. They help to determine the extinct animals. As I said, without fossils we wouldn't have known about dinosaurs. Without fossils we would never have known about dinosaurs. So it helps to determine animals that used to exist but they are no longer there. But if you're able to discover their fossils, we trace them, whatever, we realize that these are animals that used to exist but they are no longer in existence. So they help to determine extinct animal, like this dinosaur in this picture. So you realize that it's hardened to the wall. So there is not just bones, but other minerals from the rock have entered into the bones and have made it hard, solid, more solid, so that it's been able to stay for so long that over these millions of years it's still being preserved, and it's not rotten. Now also it can also, as like what I was saying, it can also be used to determine the oldest animal. For example, sponge-like fossils. Sponges are invertebrates. Yes, they look like sponge as their name goes. They were actually discovered and are believed to have been alive to up to 760 million 760 million years old. So there is no other fossil that is as old as this one. So it is believed that this animal, this sponge-like fossil, is the oldest. Or they even have gone ahead to speculate that life might have started out as other animals might have started out as sponges before progressing, and then for us to have fishes, reptiles, and the rest. They started out as sponges because this is the oldest animal. This is how it is. So fossils are very interesting because they are able to at least give us an idea as to prehistoric life, or life before our generation, or Alright, so we have come to the end of the lesson. So take note that there's an assignment about this lesson on the Google Classroom platform. Thank you all. So I'll see you some other time. Bye.